This week in lab, we'll be doing separation of a mixture. A mixture is a substance composed of two or more different types of atoms or molecules that are combined in variable proportions. The purpose of this lab is to separate a three-component mixture into its constituent parts and calculate the percent composition of the mixture. The components that will be in our mixture are ammonium chloride, sodium chloride or table salt, and silicon dioxide or sand. The methods that we'll be using to separate out those three components are sublimation, dissolving, and evaporation. So sublimation is the change from a solid phase directly into a gas phase. So that will happen with the ammonium chloride. That'll be the first thing that we observe, is that if we directly heat our mixture, the ammonium chloride will sublime off and produce a white smoke. The second method, dissolving or solubility, is where you use a solvent to dissolve a substance. So we'll be using water to dissolve our salt in our mixture. And then evaporation occurs when a liquid changes to a gas, and we'll be using that to separate out the water from our wet sand and from our salt water solution. So the procedure starts out, you weigh about 2 grams of your mixture into either a beaker or evaporating dish. For this video, we will be using a beaker. Then you'll directly heat the mixture on a hot plate. So that will cause the ammonium chloride to sublime out of the mixture, and you'll start to see a white smoke forming. Notice that our hood will be in the proper position, so that sash will be where those arrows are indicating, because when that ammonium chloride sublimes off, we don't want to be breathing that in. So we're going to be careful with that. Then after that has sublimed off, we can weigh the beaker and figure out how much ammonium chloride sublimed off. Then we will dissolve the sand-salt mixture in some water. So that will dissolve the salt and leave the sand behind. And then once we have added the water, we can decant that into an empty beaker, meaning just slowly pouring the water into an empty beaker so that we don't take any solid with it. So we want to get as much liquid as we can into that empty beaker without disturbing the solid at the bottom. And then we will heat both beakers to dry off the sand in one and to evaporate off the water from the salt mixture in the other. Then we will have 2 beakers. One will have dry sand and one will have dry salt. And we can weigh both of those to figure out how much salt we had and how much sand we had in our mixture. We will be using a beaker for these steps because we don't want any solids to splatter out, so that's why we'll be using beakers. So this is just a little flow chart to help visualize the process and also help determine how to find the masses of each component. So for the ammonium chloride, you'll be subtracting number 2 from number 3. So number 3 is the beaker with the mixture after you sublimed off the ammonium chloride, and beaker 2 is that mixture before you heated it or did anything with it. So if you subtract those two, you can find the mass of ammonium chloride. Then to find the mass of the sand, you'll subtract the empty beaker mass from the very last number 6 where you have dried off your sand. So you just take out the mass of the beaker and now you can figure out how much sand you have. And then finally for the salt, you can take off that empty beaker mass from the final beaker plus dry salt. Notice these masses are completely made up, so they're not going to be what we are going to get in the video, but I just wrote them just so you can visualize. 2 other calculations you'll be performing are the percent of each component and the percent recovery. So the percent of each component is telling you how much of each component makes up your total mixture. So when you have the mass of, let's say, sand, for example, you can divide that by your total mass of your mixture, which was about 2 grams, multiply times 100, and you'll get the percentage of sand that was in your mixture. So you're going to do this for all 3 components. And in a perfect world, those component percentages would add up to 100, but we know that nothing is perfect, so the goal is basically just to get it as close to 100 as possible. And if the percent that I end up getting in the lab video is lower than 100, you can make guesses as to maybe what could have happened that would have caused that to be low. The next calculation is percent recovery, which is going to tell you how much of the original mixture you recovered after you did all of those steps. So like I said, nothing is perfect. There could have been spilling, there could have been splattering, things that would have caused some of the original mixture to escape from the beakers, and then we would end up with a lower percent. So to calculate this, you take the total mass of each component added together, so mass of sand plus salt plus ammonium chloride, divide that by that 2 grams of the mixture that I started out with, multiply times 100, and you'll get the recovery percentage, so if you were able to recover all of the mixture or not. And these are the calculations that you'll be doing, as well as the individual masses of each component.